Hello everyone, welcome to my channel. This is my first video and I am sharing a complete lecture series on operating system. If you are a computer science student preparing for exam or just curious about how computers actually work, this series will help you step by step. So let's begin with the lecture first, introductions and basics of computer system. First, let's answer the big question, what is an operating system? An operating system or OS is a program that manages the computer hardware. It also acts as a bridge between computer users and the hardware. For example, imagine you are a computer without Windows, Linux or Mac OS. You would have to directly give instructions to the CPU and memory in 0 second and 1 second. That's almost impossible for the normal users. So the OS makes our life easier by handling all low-level details. We just applications and the OS take care of hardware communication. In short, the OS is like the manager of the company, making sure resources are used properly and everything works smoothly. Now let's look at the basic structure of the computer system with operating system. At the top, we have the users, people like us who use Word, Excel, compilers, browsers, and so on. Below that, we have the application programs. These are the apps we use every day. But these apps don't directly talk to hardware. Instead, they interact with the operating system. And finally, at the bottom, we have the computer hardware, CPU, memory, disk, and input-output devices. So the operating system is sitting right in the middle like a traffic controller, making sure every request from the application reaches the right hardware source. Example, when you play a video in VLC, it is the OS that tells the CPU to process it, the memory to load it, and the speaker to output the sound. Now let's talk about the different types of operating system. First we start batch OS. One of the earliest jobs were collected in batches and executed one after another. Users had no direct interaction. Example, early IBM mainframes. Then after time sharing OS, here many users share the computer at the same time. The CPU divides into small slices for each user. Example, Unix. Next, distributed OS manages a group of computers but makes that appear like a single system. Tasks are distributed for better speed and reliability. Example, Amoeba OS. Next, network OS, mainly used in servers to provide features like file sharing, printer access, and communications over a network. Example, Novell NetWare, Windows Server. Next, real-time OS, used in systems where response time must be very quick. Example, pacemaker, air traffic controller, and automobile system. After that, we have last multi-programming. We can also say multiprocessing, multitasking OS. Multi-programming means multi-programs in memory executed by CPU one by one. Multiprocessing means more than one CPU works together. And multitasking means users run many tasks at the same time, like listening to the music while browsing. Example, Windows Linux. After that, we have main goals of an operating system. First, convenience. To make computer easy to use without OS, we have to write machine code to use hardware. Second is efficiency, to manage hardware resources in the best way so program run faster and waste fewer resources. And last, ability to evolve. OS should be designed in such a way that new features and update can be added easily. Example, Windows and Linux keep updating with new features without breaking everything. After that, we have the main functions of operating system. Process management handles multiple processes, schedules them, and allocates them. Example, listening to music while browsing. Next is memory management. Allocates memory to program and free it when not needed. Example, running a game while browsing together. File management. Create, deletes, reads, and organize files in storage. Next is security and protection. Provides password, authentication, and protect processes from unauthorized access. Last but not the least, error detection and handling. Detects hardware or software errors and takes action. Example, showing a printer error or recovering from a crash. So today we covered what is an OS and then its structure, then types of OS, and then goals and the main functions. In the upcoming lectures, we will dive deeper into topics like process scheduling, memory management, and deadlocks. If you found this video helpful, please don't forget to like, share, and subscribe to the channel. It's really motivate me to make more content. Thank you for watching, and I'll see you in the next lecture.